Hey everyone, welcome back to another episode of Ask GN. I'm joined again by my co-host, and today we're doing Ask GN episode, I think it's number 109, pretty sure. And as always, you can leave your comments in the comment section below with questions that you've had recently, or just in general about computer hardware, and we'll try to answer them in one of these episodes. And yeah, leave your comments below. We'll go through the questions from the last episode and this week's episode, and then we'll carry your ones from this time over to next time. You can also go to patreon.com/gamersnexus to get access to our separate bonus episode of Ask GN, and unfortunately co-host Snowflake does not join me for those, but you can see some extra questions from the Discord. Before that, this video is brought to you by the team group Delta Max SSD. The Delta Max SSD has a mirror-like finish and addressable RGB LEDs to produce a large display area that's addressable by USB 2 or RGB cables. The Team Delta Max SSD is available in 250GB, 500GB, and 1TB capacities, capable of 560 MB per second read and 500 MB per second write speeds, or about 90K IOPS read and 80K for write. The Delta Max SSD is compatible with Asus, Gigabyte, ASRock, and MSI RGB software for quick synchronization with the rest of the system. Learn more at the link in the description below. Okay, so we're back to another Ask GN. As always, you can leave your questions in the comment section below. We'll not get all of them, but we'll try to read all of them and pull some aside for the next one. And then we've got the special Patreon episode as well for patreon.com/gamersnexus backers. All right, so who actually makes NVIDIA's coolers and cards is up first. This is from Andrew Cruz, who posted on YouTube last time and said a surprise to be sure, but a welcome one. Ed from Sapphire said they are the OEM for AMD cards. Who makes NVIDIA's? This is a potentially a multi-part answer because there's different cards and different parts of the cards. I'm going to start with the coolers because that's the thing I actually know 100% for fact. So the coolers for NVIDIA's, a lot of NVIDIA's products are often made by Cooler Master, and this is kind of a funny one to answer because we toured Cooler Master's factories back in March, a lot of them, and also their partner factories, so ones they don't own but they work with. And at the time, the original answer from them was, yes, you can definitely talk about we make NVIDIA's coolers for these products and list of the products. And then it was, well, actually, you can't name NVIDIA, but you can show the products being made at our factory. So it's like, okay, but everyone still knows that you're making them then. So what's the point? So anyway, there was some weirdness there with the naming specifically, but we're not at the factory anymore, so it doesn't matter. So yeah, we published this back in March, but we have some cool footage we can pop up on the screen from our tours of Cooler Master's factories where some of the NVIDIA cards are being made, the Quadras, where we got some really good shots of Quadras. We have a few specific ones, so hopefully the editors can dig these up. But the two that come to mind, there's one where you can actually see the Quadra logo and the cooler. I know you asked about the cards, but the cooler's part of the card, and this is pretty interesting stuff. So the cooler's going through the line. It's got semi-automated screwdriver assembly, I guess, for the screws. I say semi-automated because a lot of these factories will use manual effort for installing the four screws surrounding the GPU just to not crack the silicon. They typically use people for that because a person's going to have a good sense for when it feels like it's too tight and might be dangerously tight. And the tolerances between these they're pretty tight tolerances, but they're loose enough between the screws, like screw length, for example, and spring tension, and the coolers where you have the standoff height, and then the silicon itself for the height that height is varying. It's not a fixed height. It'll vary by a bit from one to the next when you account for the substrate as well. So those tolerances are loose enough where it's just safer to use people to install that stuff. And then the machine is used for all the other screws. So stuff like in the shroud, through the back of the card to support the base plate. The Founders Edition, I'm actually not sure on. We didn't see that one getting made when we were there. So I'm not positive on how the 70 or so screws in the Founders Edition cards are done. It would be shocking if most of it were not automated. But that said, it wouldn't be that surprising because I know in speaking with some of the other board partners, especially of NVIDIA, that a lot of that process is still manual as well for the screw, installing the screws and all the cooler components. So anyway, what we do have was the Cooler Master footage. And the Quadra was going through that line. It's you map the driver to the different parts on the shroud where the screws will go. It picks up a screw with a magnet, which comes out through like a screw conveyor belt almost. We have footage of those too. It's all really cool stuff. And dips down, picks it up, moves over, puts it in, spins obviously, and then does the next one. So that's how the Quadros were done. We also have footage from the Quadro, I think it was Quadros, from the heat sinks, so the actual fins, where those go through big stamping machines, and it'll stamp sheet metal. And it does it in a way that you can get the folds of the aluminum heatsink to all interlock, so that they can use one piece of sheet metal, come down, stamp it, and then, I don't remember the exact details. It's in our video of how coolers are made or how heat sinks are made or something. But I scripted it all then, so it's in that video. But it stamps it in a way that you get kind of a lower chamber and an upper chamber, and it'll interlink them, and then comes out the end of the conveyor belt as an assembled cooler. So it's just the cooler at that point. It's kind of like this Radeon one from the 5700 XT reference card. So it'll come out like that. And then typically, well, not with this cold plate, but the fin stack comes out, and then they can take that piece, move it to the next line, and continue assembly or welding, whatever it may be. So that's part of that. Also the DGX, you asked about NVIDIA's in general, but the DGX, if you remember that, it's like the multi-$100,000 mini supercomputer, I guess, or just really high-end computer. But those for deep learning, machine learning, stuff like that, AI, those are outfitted with a kind of special gold-ish colored, champagne colored, because Jensen's obsessed with that champagne colored face that's got the kind of weird mesh on it. It's like a hard mesh material that looks like it's spongy, but it isn't. And that's also made at Cooler Master's facilities, which is something we disclosed again back in March when we were able to shoot that. And I think it was another instance where we weren't supposed to show the NVIDIA logo because Cooler Master wasn't 100% sure if we should, but we were allowed to show everything else. And it's so obvious that there's no point in like saying, oh, Cooler Master makes something that looks a lot like the DGX faceplate, but we can't quite say what it is or who it's for. Guess you'll have to guess, and then pop up like a screenshot of it on the screen. That's just kind of stupid, so they make it. And that's all done at the main factory we toured. I forget if that's in Huizhou. I think it might be in Huizhou. I can't quite remember. They have a few factories in that area, and then a lot that they contract in that area. As for NVIDIA's PCB, in the past they've used Foxconn for a lot of this. Not 100% sure what they're using for the RTX series, but my best guess is it's probably still Foxconn. So yeah, a lot of the coolers are made by Cooler Master for a lot of the companies actually in the industry. They kind of OEM for other people too. And Deepcool does this as well. I can't say which companies for whom they make the coolers today, maybe one day, but Deepcool also, might surprise you, does make some of the coolers that other companies sell, which surprised me because it's not news that companies will OEM for each other, but Deepcool didn't really strike me as one of the bigger companies in the industry. And they're not super large compared to someone like Cooler Master, which is in probably 80% of the cooling products in the world. Like they're in a lot of the street lights outside on the street. A lot of that's Cooler Master product. So they're huge, but Deepcool does that for other, anyway, that's not really a GPU question. So yeah, I think the answer to your question is Cooler Master makes a lot of the coolers and cooling products for NVIDIA, and this is not anything special I'm revealing. We showed all of the stuff in March. We just didn't say the word NVIDIA, but we showed the Quadro logo on the card, and we showed the DGX solution. We were allowed to show that. So it's pretty obvious, and there's no point in trying to dance around saying the word NVIDIA. And then the PCB, I think, is Foxconn, but I'm not 100% sure on that, and there might be more recent information than what I have for that one. Next one, 4 versus 8 or 2 versus 4 sticks for motherboards. So this question is from our Discord, and NetWalker asked it. And it's a question, AMD X570 boards, is there any difference running just 2 RAM slots over all 4? This is going to apply for pretty much everyone, not just X570, so I'll kind of address it wide. I'm going to slightly tweak this question to expand it. So 2 versus 4 sticks, we'll say for a dual channel platform, and 4 versus 8 sticks for, we'll say, a quad channel platform, to give us 2 sets of options. So this will be the same as everyone else, and it's simply a bit easier to configure 2 sticks instead of 4. So some of this, let's take the EVGX 299 Dark as an example, where it's got 4 DIMM slots on the board, but that platform typically has 8 of them. It'll be 4 on each side of the CPU socket, and it runs quad channel if you have enough sticks to support quad channel. And as an aside, I should again remind everyone that quad channel mode isn't really a thing, in that there's not special memory for quad channel or special memory for dual channel. But the reason I mention it is because a lot of spec sheets, like on Newegg, will say in the memory product listing, it'll say like quad channel memory, but that's not really a thing. A dual channel memory is not really a thing. We'll still say it every now and then because that's what everyone knows, but realistically, it's the platform that dictates this, and the CPU. The memory is just memory. You plug it into the slots, and it's either dual or quad based on how many sticks you have and what platform it is. So anyway, back to the question. X299 Dark, it's got half the DIMM slots of pretty much everyone else, and that board was really targeted towards high-end enthusiasts, a lot of overclocking focus, stuff like that. It's a cane-pin product to some extent, so it makes sense. And I'm using that as an example because it's the same to X570. So, and the Impact would be a good counterpart for the X570. But if you cut the DIMM slots in half, you can move them physically closer to the socket. So that's part number 1. And this is true for something with DIMM slots on only one side of the socket too. You move them physically closer, and this helps with things like shortening the trace length. It simplifies things so that when you're overclocking, you can typically push a higher frequency, better memory configuration with the slots closer to the socket. So on overclocking boards, very frequently, and this, I think there's maybe one other X570 board that's slipping my mind right now that does half the DIMM slots, but you can let me know in the comments which ones. But yeah, typically the boards that run half the DIMM slots of their counterparts that are more maybe practically focused than overclocking focused, those will overclock the memory better, assuming the BIOS is any good and the trace layout's good. But that is one of the things that helps. So back to the rest of the question though, the difference is it's easier to push higher clocks with fewer DIMM slots, and that's really most of it. If you're not doing heavier overclocking, there could be some differences in being able to achieve the higher clocks and timings with the same level of stability that you might be able to achieve on half of the sticks. Even if you have 4 slots, but you're using 2 sticks, sometimes in our experience, it can be easier to achieve those higher clocks, higher timings with fewer RAM sticks, period. So that'll be an effect too, but doesn't matter. It'll just depend on how high you're trying to actually push things. And ultimately, you are kind of limited by Infinity Fabric anyway, because once you exit running, let's say you can do 1900 for F-clock, which we could on most of our CPUs. If you can do 1900 on F-clock, you really shouldn't be going above 3800 megahertz. And we showed all this in our memory benchmarks, but it just becomes not worth it. And so if you're not going above that anyway, then 4 and 2 slots doesn't make a huge difference, but it will be easier to configure 2 to hit the speeds and the timings and the speeds that you want. So that's, I don't know, that's my main point on it. But also though, I did want to point out, if you see boards with half the DIMMs and you're like, why would you buy X299 HEDT or Threadripper HEDT with half the DIMMs of DIMM slots of a competitor? It's because of the frequencies and the timings and the trace layout. That's really it. So anyway, I hope that helps you. I wouldn't worry too much about it, but I will say that you're going to have an easier time with fewer sticks in general when you're pushing those higher frequencies. And then if you're running like 3200, it doesn't really matter. Or even 36 is pretty achievable. I haven't tried too much though beyond that for this generation. Next one, why is CPU silicon so small? This is from Discord. VCJester asked, if die size has so much to do with heat, why are the dies on chips like the 9900K so small? Couldn't they spread those circuits out in a bigger die and make them way easier to cool? Is silicon that expensive? Does it create too much latency or require more voltage, even if we are talking about distances measured in nanometers? There are lots of reasons for this. So it's not necessarily that the silicon itself is expensive, but that the added cost of lost product and machine time is. So first off, there are reticle limits to how big a die can be. Maximum size that lithography can make would be the reticle limit. And ignoring that aspect, it's still expensive to even make chips at the reticle limit. So NVIDIA has big die NVIDIA GPUs. Those are super expensive to make. And this is also for a few reasons. One of them is that fewer chips per wafer means that there's more machine time to meet the same demand, which means it costs more to make because that machine time could have been instead used making more smaller chips. If your argument is then that you end up with the same amount of CPUs when going chiplet anyway, the thing is that you can also harvest more dies per wafer because yield will be higher because they're smaller, so there's less likely defect. And keep in mind that machine time cost is true for companies who aren't Intel especially. It is for Intel too, but especially for AMD or NVIDIA where they source fabs because they don't own their fabs. So bigger chips have a higher chance of something going wrong. If something goes wrong on them, there's less you can do with them. You can still bin them down, but meanwhile, multiple smaller chips might be capable of being combined together like Ryzen, which was really a brilliant execution of multi-chip design. So this has other issues like latency, but that's a different story. So separately, the outer edge of the wafer is lower quality silicon. And this is something you'll see discussed, especially with server products, enterprise products, where a lot of the time the center of the die is reserved for server grade silicon product, and the outer edge will be consumer because it's considered lower quality silicon. And I can reach out to other people and ask specifically why, if you all are curious. I can get some good answers on that from maybe David Cantor, some expert in the industry. So anyway, yeah, the answers to your question are, it's not that necessarily the silicon itself, the crystal, is that expensive, but so a silicon crystal is a giant tube that's basically grown, and it is diced into wafers. Diced maybe is not the right word, but it's cut into wafers, and then they'll go through and dice that into dies. And the more time you're spending on that machine making the product, because the product's bigger because you're trying to counter thermal issues, you're going to have a higher cost. It's like anything else. We could make an analog to a case manufacturer. Inwin's a great example. We talked about this with them years ago when we did the factory tour there. So with Inwin, the problem they faced was their really fancy cases that require a lot of stamping, special, like, I don't know, you might need to take a router in there for stuff, and more than just cutting some like stamping panels and moving on, they had to do a bunch of special manipulation of the metal to get that, I forget what it's called, that's why I'm stalling here. It's the case that Bob Stewart did. Bob Stewart and Rod Rosenberg did with Inwin. But anyway, it was a really complicated case. And the reason that case was $1,000 is the one with like the sword on it. The reason that case was $1,000 is because it took so much machine time. Because in that same amount of time to make one of those cases, Inwin could have made like a dozen of a lower end case that has a lower price. But when you look at margin, they're trying to equalize the margin, so they have to raise the price of the one that takes longer to make so that it actually makes financial sense to make that product. Otherwise, you might as well just make the cheaper one that sells in higher volume because it takes less time to make. And the main engineering aspects are, okay, so your problem you're addressing is thermals. The easiest way to deal with thermals is to do your best for silicon to IHS interface and then rely on the customer and the cooling manufacturers to get something that actually works. And if that means spending more money on a cooling product, that's probably going to be more desirable than spending more money on a bigger piece of silicon, which also starts to have form factor issues for things like laptops or other small products. So that's another aspect of it. A reticle limit is, of course, a big actual physical limitation where they just can't make a die bigger than a certain size. So that's another one, like for the big die GPUs. And then other stuff like latency is a different issue entirely than really worth going into here. But the thermals are sort of an easy problem to solve when you think about it. It's a combination of voltage and how good's your cooler. And for consumer parts, a lot of the time it's use a good interface and let the cooler do the rest of the work, because making the product just bigger is probably not going to be worth the trade-off. So anyway, good question. Yeah, for reticle limit and machine time. Machine time is probably the biggest one. People don't really consider it it's what drives cost for basically everything, because you could use the machine for something else and make more money, then why would you make the other product? Price has to go up, and then people don't buy it. So anyway, next question is, will a 3600 limit a 2080 Ti? This was a YouTube comment. It was a reply to my top comment. If you have questions, please leave them as their own standalone comments. Easier for me to find. This one is from deminybs, I think. Said, do you think the R5 3600 at 4.3 is enough to get full potential out of a 2080 Ti? So it depends on what you're doing. This is an easy question, though. If you're GPU bound, then yes, it's enough to get everything out of the 2080 Ti because you're GPU bound. If you're CPU bound, then no, it's not, because you're CPU bound. So when are you GPU and CPU bound? Well, you can look at benchmarks like the ones we did for the Ryzen series CPUs and see when is the CPU, when is the 3600 in this case, or the overclocked one, or it doesn't really matter. They're so close anyway, but we have enough results on those tables. You can look at the 3600, especially in the later reviews where we had more data, versus a 9900K. If the 9900K is getting more performance, more frame rate in this instance, then no, you're going to be limited by the 3600. You are not getting everything out of the 2080 Ti, because that's what we tested with too. But if you're playing at a higher resolution, and this is why we tested 1440, but if you're at a properly high resolution like 4K, then probably in a lot of games with maxed out graphics, yes, you are going to be pretty GPU limited. And in that case, a 3600 will keep up in most instances. But if you're at something like, say, 1440 and you want high FPS, high frame rate, then the 3600 and some of the games that we tested, and the charts are all in those videos and articles, the 3600 at 1440p even will limit the 2080 Ti in some of the games, not all of them, depends on how graphically intensive it is, but it really doesn't matter what resolution it is. All that matters is the GPU fully loaded? And if it is, then your limit is the GPU, not the CPU. And if it's not, the limit's the CPU. I know this is really basic stuff, but that's the answer to your question. So in some instances, you will be limited by the CPU. In other instances, you will be limited by the GPU. It depends on what resolution, what kinds of games you're playing, what graphics quality you're playing, stuff like that. And then production's sort of different because a lot of the time you're heavily loading on one device. And you should know which one that is based on the application you're using. Windows and background processes. There were a couple comments about this, but I pulled this one. So this is from YouTube. peepzorz said, regarding the issue of inconsistent testing due to Windows backgrounds updates, it wasn't really background updates too much. It's like everything. It's like background services, but updates can be a problem too. I wonder, and you can try to disable those, but it doesn't always work. Anyway, I wonder if disconnecting from the internet during each test run would help keep things more consistent. It would, and that would be a great idea. And it's one we thought of, and it's one we used to do. Unfortunately, the reason we don't do this really obvious idea is because so much stuff requires internet connectivity to even work now. Because a lot of games, just if you're not connected, you could try to run them in offline mode, but if you're not connected to internet, you're going to run into problems at some point with some game that wants you to be connected to internet. Even professional applications now, and this drives me crazy, but like the Adobe suite forces you to log in every now and then. So even if the applications, you can run them offline. There can be other issues with that, like, well, yeah, not worth going into, but there can be other issues with that. But you can run them offline, and every now and then it's still gonna pop something up and say, hey, you need to log in and validate that you actually pay for this product, even though it's pretty obvious you pay for it because you have multiple accounts and you run a production company and you pay a lot of money for Adobe products every year. But I'm just upset at Adobe for that. So Adobe and other software now also requires internet connectivity at least every now and then, if not constantly during usage. And that poses problems too. So the best solution is we do our best to stop Windows updates, and Microsoft goes in there and tweaks stuff so that the old tricks we use to stop updates don't work forever. They change, and suddenly, I don't know, maybe a year ago this one changed, but just disabling Windows Update no longer was good enough to stop Windows Update. Because we found this out, it would sneakily turn it back on when you did something like a driver or a chipset install, and so it would update again. So then you have to do other things, like you can use the Windows pause for 7 days feature ad infinitum and force it to pause, or you can do other registry tweaks and turn stuff off for Windows Update and things like that. And then what we do is, it's still important to test the big updates. So like whatever that one rep, I don't remember what it's called, that big AMD update with frequency changes, and they've had other AMD updates, like 1803 was an important one a while ago. Stuff like that, where you need to have those to make sure you're testing the newer products with the correct Windows patches. Those will pull down willingly. But for something like keyboard security patch for specific USB devices, we don't really need to download that, especially not during a test run. So we'll force it disabled as best we can during that. And then if we have data that looks weird, we're pretty good about catching it. And that does happen. I mean, like, everyone who does benchmarks a lot will tell you this, especially especially people who do like a lot of GPU and CPU testing will tell you that every now and then you get data that comes through and it just looks completely wrong, and so you validate and it's fine after that. And it was some issue that may not have ever been explicitly pinpointed, but it's off in Windows. So anyway, no, unfortunately disabling internet is not good enough because so much stuff requires it. What happens if you, and I will say we do our best to control the environment to the extent that it doesn't matter too much anyway. The only thing that matters is that we catch it, and we do. What happens if you mismatch RAM sticks? From YouTube, Andy Hutchinson asked, question, think it was too late for Paul's channel this month, but hoping to find an answer out of interest now. Okay, yeah. So what effect does including sticks from differing RAM kits have on a system? And by that, I mean nearly all things being equal, manufacturer, timings, speed, etc., except the box they came from. I don't have a big enough sample, but I've done this about 5 different systems, matching 4 8 gigabyte sticks from 2 16 gigabyte kits. Never noticed any major issues. Okay, so yeah, you got the end of it here about XMP. So we do this too for like our production systems, our non-benchmarking systems, where we just need to cobble together enough RAM to hit maybe 32 or 64 gigabytes, and we have to use kits that we don't use for reviews. So we'll cobble stuff together and make it work. From that experience, I can tell you that you're going to be tethered by the worst, like the lowest common denominator, even if you try to equalize them all. And so you might have to, for example, bring down the time, or like loosen the timings for all of them if one of them has issues running at a certain set of timings that the others do fine. So my general recommendation, or approach at least, is I'll go in and increase all of the timings to whatever the worst stick is, if it's blue screening or having issues running. And that's step number one. Frequency, do the same thing there. But the biggest issues you could run into are potential BSODs or mismatched timings, and it's best to just kind of manually tune those in BIOS, and it should work fine. It's really not something I recommend doing, just because when things go wrong with memory, it can be difficult to pinpoint that it's memory, and so troubleshooting it sucks. It's really not fun to try and troubleshoot memory problems, especially for people who are inexperienced. So I don't really recommend mixing and matching kits, but you can do it, and we've done it. And yeah, if you equalize everything except the box it came out of, your biggest challenge is going to be things like QVL. How does the motherboard interpret that stick of memory? Even if it's supposed to do the same thing as Corsair to G-Skill or whatever, if the motherboard doesn't have a profile for it, you'll need to go in there and manually tune it and make it work. And so then you should be covered from that point on. But otherwise, BSODs or mismatched timings are a problem. Last one here. This is, at the end of the last episode, we said we had a question for our Australian viewers because someone asked us something about fans. And we said, you know what? The real question is for Australian viewers, which way do your fans spin? Do they spin in the opposite direction in a different hemisphere? We got a couple of good answers. I thought I would share them with you. So Winnie Blue said, hi Steve, Australian here. Actually, due to the reversed hemisphere and thus convection flow, we instead intake hot air into our PCs, which is then cooled down and used as AC for our rooms. This is quite handy, as ambient temperature in Australia is usually hotter than what most chips run at. Fans spin the same way, we just install them upside down. You know, this is why I love viewer input. I would have never known that without going there myself and testing it. And now I know. I wasn't aware of that. Dan McLeod said, Love the cool air coming out of my PC. Too bad the cool air rises so it all dissipates. See, that must have been that cold front the other week that we got. And then Zoda Soda, another Australian here, can confirm my aftermarket heater is heating my CPU as we speak. Thinking of dabbling into water heating builds with a kettle mounted inside the case. So that'll be it for this week's AskGN. Thank you for watching. Leave your questions in the comment section below. Check patreon.com/gamersnexus to get the other one. And we'll see you all next time.